Hello everyone, hope you all are doing good. Welcome to my channel. Today I'm going to talk about some of the very important cost saving tips around GCP BigQuery. We are living in the age of technology where all the organizations have already migrated to the public cloud or they are talking about their plans for the migration. Right. And when we look at any of the cloud provider, we see a list of services to choose from. So at a times it is very natural to get overwhelming by the number of services that these cloud providers offer and the ease at which these are available for our use. But it is very important to make a knowledge based decisions to choose and to when we choose and utilize these services. Otherwise, over the longer period of time, it may very void down the purpose of going to the public cloud. So that's why today I have decided to choose or talk about one of the very important service in Google Cloud, which is a BigQuery, which is used by many organizations nowadays to perform their analytic operations. If you look at the definition of BigQuery by from the Google Docs, it is mentioned that it is a serverless, cost-effective enterprise data warehouse. So it is basically the online data warehouse provided by Google Cloud that comes without any overhead of management of your resources, management of any hardware. So you just utilize the service for your workloads and it processes your workloads on demand. It also has a built-in AI ML capabilities. It also has a BigQuery BI engine to provide some analytics at scale for your needs. Now let's quickly look at the overview of BigQuery pricing. So it has two main components. First component is a compute, which is the cost of queries. And these queries include the normal select queries as well as certain DML, DDL operations. It also includes the execution of the user dependent functions or some of the scripts. And the storage cost is associated with the storage or the actual storage of the data within the BigQuery. The compute option also has two different flavors. You can opt for the on-demand pricing or the reservation-based pricing. On-demand is basically it's again the amount of data that is scanned by the queries, and slot reservation is something that you can reserve the amount of virtual CPUs or the slots that can be utilized by your queries, right? But in both of these compute options, it is really important that our queries make the minimum or the make very efficient utilization of the resources in order to reduce down the cost. That's why this session is targeted towards the end users who are working with the BigQuery on day-to-day basis. That include the business users, data analysts. But this tips would really come handy for the users who are coming from the traditional SQL backgrounds, like data engineers and data scientists. So without further ado, let's get started with the tips. And as I walk through the tips, I'm going to also give you the live demo. So the first tip we are going to talk about is our favorite limit clause. As with any other traditional database system, BigQuery also provides you a way in which you can limit the number of records that are returned by your select query. So you can see here that we have used a limit clause with 1000 as offset for the select star query, right? And looking at the syntax, it is very natural to assume that this query is gonna return or scan 1000 records from the underneath table. But think about it. Is it what is happening in reality, right? Let's look at the actual demo in BigQuery and check what is happening. I'm into Google Cloud Console BigQuery Studio, and we are going to use one of the public dataset available within BigQuery is a Stack Overflow. I'm sure we all are familiar with the Stack Overflow, which is a social networking site or social site for the technical collaboration. So we're going to use one of the simple table within Stack Overflow badges. You can see it has a very small schema. Let's go to the details and look at this metadata information. So the number of records available in this table are around 46 million, and the total logical bytes, which mean the actual storage of this table, is around 1.96 GB. So we are going to do two things. We will do a select star on this table with and without limit clause, and we'll see what difference it makes for the amount of data that will be actually scanned bu- with the by the queries. So let me do a query on this table. I will write a select star and remove the limit to start with. And as you can see on the top right section here, BigQuery is intelligent enough to tell you in advance that the how much data this query will process, or how much data this query will scan to retrieve the result, right? And in this case, it is expected that because it is select star. So if we run this query, but before that, let me just go to the query setting and make sure that I'm not using any of the cache result, because if I may have ran this query earlier, then BigQuery tends to use the cache result in order to minimize the time required to run the query. So let me click on run. It should not take a lot of time. Just wait for a few moments till the query processed. So you can see the query is finished. It has returned the results. And now let's go to the job information to see that, okay, it has taken 8 seconds to run the query, and the bytes processed are around 1.96 GB, as well as the bytes built are also 1.96 GB. Right? So what does this signifies? That when you do a select star on this table, you will be charged for the amount of bytes which will be built from this query, is a 1.96 GB, right? Now let's assume that you only want to get 10 records of this table, right? So naturally you don't want to incur the entire cost of scanning the entire data from this table, right? So because the 10 records would be way much lower than the 1.96 GB, right? So let's add the limit clause on this select query and see what it does. The information on the top right is updated, but it still shows that the query is going to process 1.96 GB of the data, right? It means that this limit is not really restricting the data scan that the query will perform, right? It will merely restrict the number of records that will be rendered on the UI, right? Now let's again run this query and see what the job information is all about. Run the query. You see this time it is way more faster, but the amount of data that is scanned by the query is still 1.96 GB, and the build bytes are also same 1.96 GB, right? So even if there was a limit clause on the second query, it has not really restricted the amount of data scanned. So this thing is really important for the end user, that they should be aware that writing a select star is not always a cost friendly option within BigQuery. Now, with this nature of a limit clause within BigQuery, you would ask a question: are there any cost-friendly alternatives if I still want to have a look at a subset of a data before writing my actual query? Because you may be required to look at the data to do some analysis to understand how the data is structured, to understand what type of values are present in the table, right? So generally these type of analysis can be done in the traditional SQL using the limit or the top clauses, right? But we have just seen that it may turn very costly within BigQuery if the amount of records in the underneath table are too many. So the good news is that definitely there are multiple alternatives that you can use. Following are the top four alternatives that I generally use: preview option, the accept clause, then the table sampling, and finally the where clause. So let's look at them in the actual demo within the BigQuery. Let's go back to our badges table from the Stack Overflow dataset. We are into the details tab, and if you look at the top section here, we have a preview tab available, and this is where we get to view the subset of a data from this table without writing any select query. We can limit this view to render 10 to max 200 records, and we can also use the pager icon here to get the next set of records. This feature is inbuilt, natively supported within the BigQuery Studio. It means that you won't be charged or there's no cost that can be incurred if you are using this feature, right? And there is no limit on number of times the preview option is utilized from the table itself, right? So I would say this is a great feature overall, and it is in most of the cases it is sufficient enough to start with the analysis of your data, right? So you get to know that what type of data is present in the table, what are the columns, what does it look like, and so on. So that's basically the starting point for any investigation or any type of analysis on the table. Now, there are different types of clients that are supported by BigQuery because not all the users will be directly interacting with the BigQuery from the studio, right? So there are variety of other clients supported like Cloud SDK. There can be some applications which are connecting to the BigQuery using the Cloud SDK APIs. There may be the REST APIs written by the web clients, or there can be users who are writing the queries on BigQuery using the Jupyter notebooks. Those Jupyter notebooks can be situated either in the Dataproc clusters or these can be in the user managed notebooks. So naturally for them, since they are not connected to the Google Cloud Console, the BigQuery Studio won't be accessible directly and they cannot make use of this preview feature. Now, what is the option for them that they can still have the preview of data without incurring the full cost of the full scan of the table, right? Or doing the select star on this table. So that's where our third alternative tip comes handy, which is about the sampling of a table. Right? This is also, I would say, a unique feature that is supported by BigQuery that you can retrieve a sample of records from a table, and that will limit the amount of data scanned by the query, right? So this is a select query. As expected, it is going to scan the entire data from the table, and I'm going to change this query to add a table sampling clause here. Table sample system 1%. As we can see on the top right section here, the uh, BigQuery has given the estimation that it is going to scan 105 MB of data from this table. And if we go back to the details of the table, we know that it has around 2 GB of data total. Right? So this is still a significant improvement on the amount of data scan. So we are still doing a select star. So let's run this query and see the actual output. Okay, the query is finished. You can see the sample output here. You can also see how many number of record it has retrieved from the original table. And if we can go back to the job information, this is where you see the amount of data that is scanned with this query, right? So we have achieved a significant reduction on the data scan here with the select star, and this tip is essentially very helpful for all other clients which are not directly working with the BigQuery Studio, as I mentioned before. However, one thing which is very important to note in this case of table sampling, that as the name indicates, it is basically a sample of a record from the table, right? So it randomly selects a sample and returns that sample as a result of the query, right? So there's no guarantee that the same sample can be returned for the next execution of the query, right? So please remember that don't use this query to run any production job where you need a guaranteed output of a query, right? So there's no guarantee with this query that it will return the same output with the next execution, because it just mean for sampling of your table, and this is very important, or this comes very handy for the users who want to get a view of a subset of a data and they cannot use a preview option. Query stores table data in a columnar format. It means that the value of each column is stored separately. As against to a traditional row-oriented databases, BigQuery is a particularly efficient at scanning individual columns or the entire record set. Right? So what does this mean? Let me give an example. Let's say we have a product table with the sales amount of the product for different orders. And let's say this table has millions of rows. If I want to just get the aggregated amount of sales value for all the products, I will write a query that selects sum of sales amount from the table. So in a traditional row oriented or a record oriented database, what will happen that the query will first extract the result or extract the entire data set from the table, perform the aggregation, and then displays the result, right? But in BigQuery, because it is a column oriented data store, that it will only target that particular column, performs aggregation, and then displays the result, right? So thereby reducing the amount of data that can be scanned or the number of columns that are required to produce the output. Now, in this session, we are only talking or targeting the end users of the BigQuery. So we really need to worry about how it works under the hood, what type of algorithms or compression techniques are being used. But at the same time, being a end user, we need to be aware of a smart way to utilize this feature in order to write the efficient queries, right? And that's where I'm going to introduce a next tip, which is a except clause that can be used in conjunction with the select queries within the BigQuery. So to demonstrate this, let me take an example of a table which has a wider schema than our earlier badges table. So this is a post questions table from the Stack Overflow. Let's go to the review and check what type of data it contains. Okay, so it has some system generated ID, title, body, which is a long textual column. It looks like the HTML of the post, and it has some other columns like accepted answers and so on. Now looking at this data, I know that in my query I definitely don't need ID to do any kind of analysis. It looks like some system generated ID. I also decided that I will not go with the body because it's long textual information that may not be required for my analysis. So I've decided that I will load this table ignoring these two columns, right? So this is where we can use our except clause. I'll go to the table schema, click on the ID column. As you can see that as soon as I clicked on it, it has created a select query with that particular column selected. So this is also one more smart way to write the queries on the BigQuery if you are using the BigQuery Studio, obviously. So let's check the amount of data that can be scanned or that will be scanned. If we do a select star, it is 37.17 GB. Now let me write except clause. As you can see that it has immediately updated the approximation of the data scan, which is to 37 GB. Let me add one more column which I don't need in my select query, which is a body. And now you can see a significant reduction in the amount of data scan, which is 3.49 GB, right? So from all the way to 37 GB, just by excluding these two columns which are definitely not required for my analysis, I'm able to cut down the cost by this significant reduction, right? Let me run this query and check the actual output, right? So this is a powerful feature, I would say powerful tip. If you're sure that there are certain columns in the table which you are definitely not going to need for your analysis, it is always recommended that you put those into the except clause so that BigQuery doesn't need to read that column and cost you the money for scanning that column, right? Let's go to the job information. I can confirm that it has scanned only 3.49 GB of the data from the underneath table. Among the other few important tips that I want to talk about is a with clause or a common table expression feature that is supported within BigQuery. It acts kind of like a temporary table that you can reference at a later part in your SQL query, right? It actually binds a result of your subquery to a table name, and then that table name can be referenced elsewhere else, right? So lot of developers use the with clause very often in their SQL queries to make their queries more readable, more organized in the different modules and so on, right? But at the same time, it is very important that we should be aware of certain caveats that come with the BigQuery, right? So let's go to the BigQuery and look into the actual demo. Here I'm displaying a some simple with query. The syntax here shown that there's a with clause at the start, and we are creating a table with name test table. I'm just putting in some sample data, first name and last name, and then I've added another record for Virat Kohli as first name and last name, right? Then I can reference this test table in the select query that I've written later. Select start, and then I'm gonna concat first name and last name from the test table, right? So if I run this query, you can see that I get all star means everything from the test table, but I have done some transformation on the data from the first table and so on, right? So you can see the importance already, right? So you create some standard data for your use, and then you manipulate that data at a later stage and so on. You can go up to any level of this with clauses, right? You can create your own small data island and refer that at later in your query to do some additional computations, right? So as long as the size of table is small, it shouldn't be a cause of worry. But now let's look at the query which is doing certain complex calculations or scanning a lot of data, and we have a with clause, right? So what will happen in that case? So let me again go back to our Stack Overflow data set. I'm gonna refer uh, two very popular tables from the Stack Overflow. The first one is a users table. If we go to the schema or the preview this table, it has a display name of the table, the profile of the table, age, and so on. And there are some metrics also. It has a reputation, so it's kind of a score that is generated by the Stack Overflow based on the reputation of that particular person. And then we also have the comments table, which again has the details of the users, what type of comments they have provided on the topics that are there in the Stack Overflow, and also what's the score that they have got for that particular score, right? If you if you already use Stack Overflow, you would know that if someone likes your comment, you will get certain score for that like, right? Or if your solution is accepted at answer, there will be a certain score associated with, right? So I'm gonna write a query which performs basically a join between these two table based on the ID, uh, with the user ID, and then I'm gonna determine the reputation of the user along with their score, right? So this is my query. I will first create a base table, and then here with the users I'm joining the comments table on the user ID, and from the users table I'm going to retrieve these sample columns, and from the comments I'm going to retrieve their score, right? So this is a base table that I've created, so this will give me the actual base data that I'm interested in. And at a later stage I've then filtered out this particular table for a specific country, because I'm only interested in certain location with this query. And then I've just grouped the entire result sheet with the display name so that I get the aggregated values of the reputation and the score for the particular user, right? So let me run this query, and will see that. Let me also apply a limit clause so that we limit the output to only 10 records. Yeah, the query is running. It has displayed the result. We know that now these are the top 10 users from the India who are active and with a very high reputation on Stack Overflow. Now, now remember here that the important thing to note here, right? So whenever you refer this particular base table in any of the query, BigQuery is gonna scan these two tables, perform this join, and then apply these transformations on the table, right? It means that the result of the base table are not materialized by the BigQuery. So let's say I have written one more statement here that I need a certain amount of data from the UK location, right? So this query would mean that BigQuery will again go and scan the tables, users, and comment for these information, and then perform this computation on top of that table, right? So this is something our users should be aware of, that with the with tables with this CTs, these are just given for the readability. It doesn't really help in reducing your data scan, even though it has done already here, right? So please remember that whenever you are referring a table with a with clause which is generated by the CT, it is going to be scanned again from the by the BigQuery engine, right? So the best way in such cases, right, let's say if we want to always combine these two tables, join these two tables, and then perform some aggregations on top of it, I would recommend that you create a table, a new table, materialize the result of this join into a new table, and then write the queries on that new table instead of writing it with the with clause. That would avoid a lot of data scan that can be performed by the BigQuery under the hood, right? So you can give it a try. I will let that you do that experience on your own and share your findings. One more cool tip I would like to talk about is the use of approximate aggregation functions within BigQuery. So from the traditional SQL background, we are already familiar with the aggregation functions like sum, count, and so on. So these functions perform the task of doing the aggregations of the data and returning the results of those aggregations, right? And as we can see that if the data volume is too high, the aggregations may end up taking a lot of time, right? And we are talk about the case in BigQuery that everything is dependent on the time, the slot hours that are utilized by your query and the amount of data scan, right? So we should always try to reduce both of this when we are writing the query. And to do just that, to reduce the amount of time required to execute the query, there's a ability to also do the approximate aggregations within BigQuery, right? And these can be really helpful in the instances where you are not really specific about the actual numbers of the data, right? You're just willing to understand the high level trend of your data. We are willing to compromise the exact numbers, right? So those are the ideal scenarios where you should go with the approximate aggregation functions instead of using the exact aggregation, because these functions are scalable in terms of memory and time. So let's look at the actual demo in BigQuery and check what impact it makes if we are writing this normal aggregation query and the approximate aggregation query on a table. So I'm into the BigQuery Studio again. Gonna use the users table from the Stack Overflow dataset to demonstrate the use of approximate aggregation function. So let's quickly check the schema. So we have the user ID in this table. We also have a creation date. So what I'm gonna do, I'm gonna write a query on this table to understand how many users are creating a profile on Stack Overflow per month. So we will group by the creation date or the month part of a creation date, and we will count the distinct IDs. And we'll write this same query using the exact aggregation function and the approximate aggregation function, and then observe the difference between the execution time. So let me open the table in the new tab. We'll do select ID, extract month from creation date, group by Since we are aggregating here, so we need to add that into the group by. Okay, so the query is complete. It's gonna process 285 MB. Let me run this query. You can also observe the execution time on the top when the job is running and job is finished. And we can see that it has taken 5 seconds to run the job, and we see the output here. For the first one, we can see that the total number of distinct users who have created their profile are 1.52 million, followed by in the second month it is 1.46 million, and so on. Of course, the result are not sorted. So let me now run this query using the approximate aggregation function this time. Okay, so as you can see here, the amount of bytes that will be processed by the query will not really change because it's gonna do the scan of the similar set of data that is required, but it will make a difference in the execution time. So let me now run this query, and voila, it is already finished. We go to the job information. It takes only 0 seconds, right? So it means it is less than 0 second to perform this aggregation. Now let's quickly compare the result. In the original aggregation, we have seen that for the first month we had the count of 1.52 million. Now let's check the count in approximate function. It is again 1.52, but after 52 it is 3363, and let's go back and check here. It is 9539. So there is a small difference. So as long as you are okay with these kind of differences in your number, I would always recommend to use the approximate aggregation function, because that will save your time of the execution of query. It requires less memory when BQ shuffles the data internally, thereby reducing the slot execution time of your resources. Now, one last and most important tip that I would like to talk about is to have a general awareness on the data that you're working with. Because with the great power of BigQuery, it is really important that we make the knowledge-based decisions when working with the data, right? So one of the example of such a scenario is, let's say you have a skewed data in your table, right? And you're trying to write a query. So what happens under the hood? So let's take an example of a product table where we have millions of records where the product sales are recorded along with the other attributes, and we are trying to query this table to get the sum of all the products, or sum of sales amount of all the products, right? And let's imagine that one of the product is a star product of our company where 90% of sales are happening, and all other products constitutes to only 10% of the sales, right? So naturally the number of records for this product one are way more than the other 90% of the products, right? Now when you do a query on such a table where the data is very much skewed to just one product, what happens internally, right? BigQuery tends to, or it likes to have a worker allocated for each product of the table internally, right? So what will happen in this case, all your other 90% product, the workers associated them will finish their work, and they will wait for the worker who is processing the results of a star product. Although BigQuery will do some intelligent reshuffling of the overloaded worker internally, but we we can restrict it to go to that level itself, right? If we identify this skewness of our data and then we try to remove the skewed value from the table, then we may not end up in this situation altogether, right? So these kind of parameters are really essential to understand, and to know that when you're working with the data you should be aware of such patterns of your data. So ideally, in such cases, right, when you have to, or you want to avoid such nature of your query, it may be ideal that you query the results of your star product separately, and then other 90% of products separately, and then do water transformation with your data. If you want to combine that, you can use the union and so on, right? So that's how you can avoid these kind of pitfalls. Thank you for watching this video. If you find the contents relevant, don't forget to like and subscribe.